So let's get started. Hi, my name is Deepak Dayama. I'm a product manager here in the container services team at AWS. Today we are going to talk about containerized app development with AWS Fargate. It's a technology we launched at re:Invent 2017. We're excited to go over some of the details of the product, and not only that, how to get started with it, and some of the recent updates we've had since launch. So this is a 300-level session. We'll go over. Clicker is too fast. So we'll go over, first of all, what is the motivation? Why did we build Fargate? Secondly, apart from where it sits in the container ecosystem and the different layers you need to think about, how to actually deploy your application with Fargate, and how to think about this as your sort of data plane layer. And thirdly, some of the new enhancements that we have launched after the Fargate launch, both for ECS and for Fargate. So at first we had EC2, right? You could just have a virtual machine delivered via API. You could get as many as you wanted, scale up, scale down based on your requirements, set up your auto-scaling groups. That was wonderful. And then came Docker. It enabled you to move to microservices, lower your footprint, shift workloads across environments or data centers, or just run batch jobs in a very efficient way. So you could now run hundreds or even thousands of containers, have a lower footprint of them, have to provision fewer servers. It's not one application, one server, and have your model more agile that way, and also get the benefits of portability. But you still had to bin pack them. You still have, even for launching thousands of containers, you probably need a few dozen or maybe a few hundred instances to launch them on. So you have a bin packing problem, cluster utilization, and cluster management problem. And moreover, a cluster state problem. How do I know certain instance is working for me, whether it's healthy or not? How do I scale up and scale down that cluster while I'm launching for my applications? So we launched ECS. What ECS does is basically it's a fully managed, for those who don't know, it's a fully managed orchestration platform, and enables you to do just that. It operationalizes your containerized workloads at very high scales without requiring you to install any software that runs as a master. It's a multi-tenant service that you can run and spin up as many clusters or services or tasks underneath. The placement, the placement engine and the cluster manager play different roles here. The cluster manager maintains the health of the instances that are part of your cluster. You set up auto-scaling groups and register with your ECS clusters. The ECS is now aware of what is the capacity that you now want to launch your containers on. Whereas the placement engine enables much advanced techniques for placing your tasks, so that if you have a certain task that you want to land on a particular instance type, or if you want to get super efficient bin packing for better economics, you can do that. And finally, we have the scheduling and orchestration. The service scheduler of ECS enables you to run your containers based on the intent of the application itself. You want it to run as a highly available service that spans multiple availability zones. You can do that. It manages the task scale based on the metrics as well. So if you want to have to launch more containers for your application to horizontally scale for incoming traffic, for example, it does that automatically without you having to worry about it. So that's the purpose of these different components. Yet, you find that you still end up managing more than just containers. So if you really look over here, you're running 2 containers that are running, or rather tasks here. A task, by the way, is a collection of containers that run together as a unit of your application. So in this case, you have an EC2 instance. You're launching tasks on it, And to support that, you have to manage the operating system. You have the Docker agent, the ECS agent, which is an open source component, but you require it to register your ECS instances with your cluster. So there's patching and upgrading OS, the agents, and scaling the fleet for our optimization. That all that is required at the same time. So you still have multiple layers of management. And this is what your layers of management end up looking like. You have a completely managed orchestration or container management layer. At the same time, you have these different layers of software management just to run your applications. All you wanted here was to just run containers. And Fargate enables you to do just that. So if you notice over here, there's no management of instances. Your infrastructure is ready to scale as your application is. There is no sort of two levels of management of scale anymore. You only define your requirements for the application in terms of a task. How should this service scale? What are the metrics we care about? And how many more such containers or tasks do you want ECS to launch? So that brought us to AWS Fargate. We built it and launched in November 2017. And the benefits are it's completely managed infrastructure. You don't have to worry about patching or upgrading or have to worry about, well, how do I pick the right instance type, instance size, and get the right bin packing for my cluster, or anticipate for unknown peaks that I will see in my as part of my my application. So, and it is fully integrated with the AWS ecosystem. So we have, over the years, invested in making the task or the container a first-level primitive of the AWS platform, which means when it comes to IAM resources or networking or be able to have integration with load balancers or integration with the AWS VPC, that is all built into ECS, and AWS Fargate takes advantage of that. So your ecosystem looks something like this. These are the services that we offer for container management. When it comes to container management, you have two different variants. We announced Amazon Elastic Service for Kubernetes, called Amazon EKS, at reInvent. It's in preview right now, and we do plan to launch it sometime later this year. We also have Amazon ECS, which I introduced a little earlier. But at the same time, you have, regardless of which orchestration platform you choose based on your preferences or your existing tool chain, you can choose one of two different launch types. You have an Amazon EC2 launch type, which was the pre-Fargate only flavor that was available. And now you also have AWS Fargate. Today, you can launch on Fargate only using ECS. I do want to note that. At a later time, we will also support that for Amazon EKS. And then you need to store your images somewhere. Your containerized images can be stored on Amazon ECR, the Elastic Container Registry. You can use it regardless of which orchestrator you're using. Some of our customers even use it for, even on-prem or something that they just run, locally on AWS without any orchestrator, for example. So it's really universal in that sense. So who's using Fargate? It's been 3 months, 4 months. Producthunt, it's a marketing toolkit for makers, for people to be able to ship products. They moved all in on Fargate and on AWS as a result of Fargate earlier this year. They started with a POC, and their requirements were not uncommon. They wanted to manage as low infrastructure as possible while still regaining control over the network policy and the security of the application that they are deploying. So the thing they liked about Fargate was it scaled quickly for the production traffic when they did a POC. They could run multiple services in a highly available manner in the ECS clusters. Their architecture looks something like this. So Fargate not only solved their abstraction of infrastructure and how containers run, but it also gives them control over the networking and the policies that they can set. For example, our integrations that we have built with VPC enables you to do routing between Fargate tasks, just like your EC2 instances can use the routing table. You can implement your security groups policies, just like you do for your EC2 instances or at an ENI level, because each Fargate task gets an ENI. We'll get into networking a little bit later, but that fulfilled their requirements. This is not something that they were able to get based on some higher level abstraction platforms that they were looking at, so Fargate sort of really met the sweet spot there. Now, in this case, they are running multiple services. They have node-based front end and using Rails and GraphQL backend. For them, they actually used the notion of ECS services, which is very common. It is integrated with the load balancer offerings that we have. So your tasks register as backends for the load balancers automatically as part of the ECS integration. Here are some of the other customers. The first quote you find on the right is from Producthunt. Shimon, on the other hand, as a very straightforward answer, is that we just don't want to be in the business of managing clusters. It's not what our focus is. You just want to launch your applications. So some of our customers have worked with us, launched on Fargate their production workloads, and also given us very valuable feedback. So now we'll get into, OK, so how do I run my containers with Fargate? The first is, let's just talk about some of the constructs. And it is important to note here that from a service standpoint, Fargate is not a different service that you have a different endpoint that you have to hit per se. You use your orchestrator, and those are the APIs, and that is the interface you work with when launching your containers on Fargate. It's just that you have to do much fewer steps now because you don't have any of the other cluster setup involved anymore. So the first construct is task definition. It's how you define your application. This includes all the different container images that you want us to launch from. It includes the networking policy. It includes how you want us to do logging. We'll cover all of these areas in greater detail later in the presentation. But this is essentially the schema that you define to define what your application should be. Now, the second is a cluster. A cluster, until we launched Fargate, a cluster really meant a cluster of capacity, EC2 instances, and how much you're using as part of the cluster. With Fargate, especially if you use a cluster which has no capacity or no EC2 launch types, is just an administrative boundary now. And I'll get into how the permissions at the cluster level work. But now you simply specify this is the administrative boundary within which a environment is set up. For example, you can have a dev cluster, a prod cluster, just for separation of applications, same application perhaps, in these different environments. A task is an instantiation of your task definition. It's a collection of containers, up to 10 containers, that you can run together. It's a unit of your application. You can add some of the utility software to go with your application as a different container. They all share the same networking interface. So you can apply a uniform policy to them. And you also have the notion of a service. This is where the service scheduler comes in. The service scheduler maintains the desired state of your application. How many tasks do you want to run? Do you want to run 3 tasks in each AZ and in 3 availability zones altogether? Service scheduler makes sure that that is the case. We replace tasks that have gone unhealthy with new ones and launch them and place them. So let's now get into task definition. Over here you have task definition. It's an immutable version document, so you can have within a task definition, you can have several revisions. Whenever you change it, you can actually do a trigger a new deployment and be able to replace your existing tasks. Within the task definition, you specify where you want us to launch or pull the container images from. ECR works with Fargate right off the box. The other registries we support are all public registries that you can use. We are also working on supporting third-party public registries. So if you have something that's username, password based sitting in your VPC and you want to use that instead of ECR, we will be enabling that use case soon as well. Now on the compute side, Fargate being primarily this container compute primitive, so running the ECS orchestration itself continues to be at no additional charge. You only pay for what you use at the request at the task level. And the dimensions that we use today are CPU and memory. So you define what should my task level CPU and memory be, and your configurations can range from as low as 0.25 vCPU to 4 vCPU. We'll get into that. But essentially, this is sort of the size within which all your containers share the same resources. Prior to that, you always had container level resources, which is what you define as limits for soft limits or hard limits for your containers, so that you know when your container exceeds a certain hard limit, maybe something is off. But you can continue to define that at the container level, yet your containers will all still share the same task level resources you have defined, because that's what you pay for. We have 50 different configurations supported today. For each of the CPU options, you can, based on your memory heavy or CPU intensive workloads, you can pick your CPU to memory ratio and a particular configuration among these, and you can go as high as 30 GB for memory and as low as 512 MB. So from pricing perspective, you only pay for what you provision, which means you only get billed for the time your task is running. Your billing begins when your task image pull begins. Until then, all the infrastructure set up, getting your ENIs ready, getting your task set up in your VPC is taken care of by Fargate. And as soon as the task is terminated or it dies, your billing stops. It's on a per second granularity, and you have 1 minute minimum for the billing. So let's talk about networking here. So we have VPC integration. What I mean by that is when you launch your tasks in Fargate, you specify the subnets within your VPC that you want to launch the tasks in. The network interface that we provision for your task it belongs to that particular subnet. So that way your network policies just apply as is. You don't have to change anything over there. Under the hood, what do? We actually provision ENI, a networking interface, which is allocated which gets allocated a private IP from your subnet. The ENI is attached as part of your task setup workflow. We take care of setting up, provisioning, as well as deprovisioning when your task terminates, for example. So this process is rather transparent from a user's perspective. But once you have a private IP, your task is ready to do image pulls and be able to talk to the outside world. You can optionally also specify a public IP for your tasks if that's something that you need for your particular application. So here's the VPC configuration. If you look at it, the networking mode here is AWS VPC. This is a mode that was launched again at reInvent. Or actually a couple of weeks before reInvent. But what this mode does is basically we had bridge and host mode until then, where your tasks would share the same networking interface for communicating outside. But with this networking mode, what we call AWS VPC, it's dedicated ENI to each task. So your network policy and application policy can now actually be the same. You're not reduced to lowest common denominator, you get better performance. And other features like that come with the ENI, like VPC flow logs, just work as is. So in this case, for the task definition, I have specified the networking configuration. I've given the subnet ID. So it's important to note that if you want a multi-AZ application, you specify subnets that are in different AZs, and that's sort of an implicit multi-AZ deployment that you get out of it. You don't have to separately have to specify those availability zones. So with respect to the internet access, the ENI is used for all inbound and outbound access. So you have to talk to other AWS resources, for example, which may not have a private link yet. You have to talk to the outside world. You need to you use the task ENI. We use it for image pulls as well. So any image that you provide as part of your task definition, we use the networking interface belonging to the task so that the networking policies apply. And also, we use that for pushing logs to CloudWatch log. So there are two common modes of setup. We'll go over each one of those. The first one is a private one with no internet traffic, but you do want to be able to talk to the outside world for the endpoints that I mentioned before. The second one is a public one. So in the private task setup, you have an ENI over here. You have you have not specified public IP. You have set up your NAT gateway and your internet gateway in the routing tables shown below so that your default route points to each of them. The internet gateway sits in a public subnet, and the NAT gateway is actually NAT gateway sits in your public subnet, and your task sits in your private subnet. So the other setup we have here is a public task setup. In this case, excuse me, it's rather straightforward. You specify the subnet you want us to launch the task in, and you also specify that you would like us to use a public IP. So you say public IP is enabled for this particular task. So moving on to the topic of load balancing, how does the elastic load balancing work? I do want to note that only the application load balancer and network load balancer is supported, not the classic load balancer with Fargate. So you register your target types in the same way you used to as you did earlier, but you do want to note one thing is that from a target type perspective, you cannot register an EC2 instance anymore because there's no instance to register. It has to be an IP target type that you will register. So in the task definition itself, you can specify the port mappings you would like us to give. Sorry about the font. It seems a little smaller than what I would have expected. But essentially, you give the port mappings within the container definition itself that will map to your that will be registered as backends for your load balancers. So here is the API example. What you have is I'm creating a service here which needs to register with a load balancer so that all the backends that come up as part of the service, all the new tasks that are launched, register with the load balancer that we have. And here I've specified the load balancer configuration, including the target group, as well as the container name for which the load balancer will front the traffic for. So this is an example that you can actually use for internet-facing elastic load balancing. In this case, you have a private task in a private subnet and your ALB in a public subnet, and you want to make sure that they are in the same AZ, and you set up your ALB rules to allow incoming traffic to be able to speak to your task, for example. So in this case, you do want to note that the task security group needs to point so that your application load balancers traffic is allowed into your task as part of your security group definition. So moving on to storage, what are the storage options that are offered today? As of now, Fargate only supports ephemeral storage. It is backed by EBS. We provide two different types over here, two different volumes that are, the use cases are a little different here. One is we call writable layer storage for your containers, and the second is volume storage, and we'll just talk about that right now. From a layer storage perspective, your Docker images are composed of multiple layers, and the topmost layer is what you can write to. It is only available to the container. Other containers cannot view it, but you may be writing some temporary data to it. And the space available for that across all containers is 10 GB. We also have volume storage. Now, you may have use cases where you want to be able to write to a ephemeral storage, yet the data should be visible from different containers, or they're probably writing, for example, logs or something for to be emitted, which is as part of the same task, for example. So in this case, you have a 4 GB volume storage. It can be mounted to different mount point, but it is across the task. So it is 4 GB across the task, shared for all the containers. You share the volume, and you do not specify the host path because the source path here. So again, that is also ephemeral. It is terminated as soon as your task is. Now I do have to warn here. We are getting into IAM permissions. This space may be a little more involved. So bear with me for the next few slides. From a permission model point of view, you have 3 different layers of permissions. The first is cluster level permissions, which is who can actually run tasks or services or view them within my own cluster. So as I mentioned earlier, cluster is now just an administrative boundary. So this is how you implement that. Secondly, who can actually, what are the resources that my task or application can access in the AWS ecosystem? So if I want to use a specific S3 bucket or a DynamoDB table, this is where it comes handy. Excuse me. So we call it the task IAM role. And thirdly, what we call as the housekeeping permissions. These permissions allow us to be able to take certain actions as a service on behalf of the application based on what you want to do. For example, create ENIs as part of your task creation workflow, be able to send your logs to CloudWatch logs so they are under your same account, or be able to do an image pull from Amazon ECR. Sorry. So the cluster level permissions, you can actually tailor the permissions to be able to, let's say, a particular user can only have access to this particular task definition. And this is the resource that the IAM user can access. Secondly, you can also say, well, I want to give read-only access to certain users because they just want to view what's going on in the cluster, what are the applications running, but I don't want them to do run task or create service within this particular cluster. So you can use cluster level permissions to implement those policies. From an application permissions point of view, this is the task role that I was speaking about. So in this case, your application runs under a particular role, and which you want us to run it as. So just like your EC2 instance can run as a role, there's the same concept here. So if you want to be able to get credentials down to your task or be able to access other, as I mentioned earlier, DynamoDB table or SNS topics, you want to use application permissions or what we call as a task role. To be able to implement that, you need to set up a trust relationship with ECS tasks. This lets us assume the role and pass down the credentials as we get them. And you need to add this ARN to your task definition so that we can identify which particular role you want this task to run as. So this is integrated with the AWS CLI or SDK, and it automatically uses the task role credentials when talking to different services within AWS. The next is housekeeping permissions. So what I mean by that is to be able to take certain actions on your behalf, we use these permissions. So there's a new role that we introduced around the same time as we launched Fargate. It's called task execution role. What it does is basically it lets us send logs to CloudWatch logs or do an image pull. And we'll keep adding more functionality there which the service takes on your behalf, but it's still for your account, for example. And then there is a ECS service linked role. So I would like to separate these two. The first one is it's an execution role. Here in the case of execution role, it's a default policy that it comes with, but you can actually modify it to be able to let the service take only certain actions on your behalf. The second is a service link role, which needs to actually create tasks, task ENIs, for example, and that's something that's a must-have, really. So in the execution role, as I mentioned earlier, you do basically you can specify a container registry read-only policy. You can write to CloudWatch logs, so you have to give these two permissions here. In the execution role, it comes as part of the default policy, and you need to establish trust with ECS tasks. So you need to add the execution role as part of your task definition. Now, the service linked role for ECS, it's a unique kind of a role over here because it actually is related to an AWS service that you are using. So in this case, the service is Amazon ECS, and it is automatically created on your behalf if you're using the console as part of your ECS cluster creation. So it's something you don't need to worry about really from a creation or setup point of view, but it's definitely something to be aware of when we talk about service linked role for your containerized apps. It has a predefined policy that we set for the service that is required to be able to do certain actions. For right now, it's specific to ENI and ELB permissions. Excuse me. So moving on to visibility and monitoring. So I deployed my task. I know how to set up networking. I know how to set up the permissions. How do I now monitor now that the application is running? We have options of logging. So the one that we have introduced as part of Fargate launch is CloudWatch logs integration. We call it the AWS logs driver. So if you look in the log configuration over here, you will see that for each container, you can specify which particular stream prefix you want the container logs to go to, and the log group that you want to send us to, and the region, of course. This is something that is supported today for Fargate and ECS. But you do want to make sure that when using CloudWatch logs, your policy allows for us to do that as part of your task execution role. Here is a screenshot of how to actually just view it in the console itself. It's built. You can optionally go to the CloudWatch logs console, but here it's built into the ECS console itself. So you can look at your application, your task, and for each container, there's a drop down to see, well, what is the STD out, for example, for this particular container within the task, and it's a nice integration. You don't have to jump back and forth. There are some other visibility tools. We also made some enhancements in the visibility area, which I'll cover as part of the next section, which is the What's New section. The other visibility tools we have are CloudWatch events on task state changes. This was built as part of ECS itself, so this is no different whether your task is running as an EC2 launch type or a Fargate launch type. We also have service CPU and memory utilization metrics. These are the metrics we use to be able to scale the tasks based on the thresholds that you have provided, or scale them in or scale them out, basically launch more tasks. They are also available in CloudWatch. So there are some functionalities that we launched recently as part of the new platform version for Fargate. By the way, for each of these, I do want to note that all the What's New section, all the functionality that we introduce, it's really built for ECS, regardless of which launch type you use. You can choose to run on EC2 instances or Fargate. It doesn't matter. The features are really for at the container management layer. So the first feature is task metadata. What it does is, earlier you had access to the underlying EC2 instance. So you could actually monitor or try to look into what is going on in the task. But now, with Fargate, there's no notion of an instance anymore. So you can actually query the task data even from within the task itself. So running as a container, whether it's running from as a Datadog container, as a sidecar, or your own, one of your containers can simply query this task metadata to get all the information about what's running in the task. These are the two endpoints that we expose. The first one we have is metadata for the task itself. It shows all the tasks and the containers, when certain containers started at or stopped at. We'll get into that in a second. And the second one is Docker stats. We just emit that. This endpoint is really sort of a pass-through to see what Docker stats you could access before directly by using the Docker API. So these are the two endpoints. You can do it at the task level as well as the container level. I do want to note that too. This is the information part of the task metadata. I've snipped out some container level part of it, which covers what is the task level information. So one is, what is my task on, and what is the version of the task definition that I'm running right now, and what is the status, for example, and even the cluster name here. So if you look at this is some of the container level information that is bubbled up. One is, what are the Docker labels that I'm using? What are the container definitions that I'm using? Where is the container image taken from? When did the container start, stop? And, like, for example, when did my container pull begin? So things like that are embedded into this particular information. Here's an example here with one of our partners. You can choose to work with any of our partners here if that's what you're doing. So here you're doing, sorry about the flipped title here, but here you're doing basically monitoring with Datadog. And what you can do is it does Datadog auto discovery, looks for Docker labels. For example, in this case, it's a Redis container, and it's able to surface information for all Redis containers that are running in your cluster. So it auto-detects your application. The second feature here is container health checks. You can define custom health checks. Sometimes it is not enough that the container is running, but the question is it healthy? And uptime is not always the same as a healthy container or a healthy task. So what we have introduced as part of container health checks is Docker health checks that you can specify using a custom command as part of your container definition itself that you want us to run so that we can report whether the container is healthy or not. You can specify sort of things like timeout, retries, or even time you want us to wait before we check for container health check, for example. Excuse me. And lastly, but not the least, it's a pretty major functionality that we launched, which is managed service discovery for ECS. Again, it's available for both EC2 launch type and Fargate. It's a managed service registry where your services integrate and run with Route 53 auto naming service. You register your backends automatically as part of the integration, and you can have multiple client backends that are part of the same service that you get as part of the DNS capability that we have. You can span it across clusters if you want. So this is how it works. The first is, Route 53 provides the naming service APIs. We create a namespace as part of that, a private hosted zone-like structure, and you can have C names per service. So basically, you can say, for this particular service, we'll have IP-based C names here registered. What we do is, as part of the task ENI bring up, when we allocate a particular IP from a subnet, we register that as backend with Route 53. So as a result, you can actually have, from an ECS scheduler point of view, it's seamless where as part of the provisioning workflow of your task itself, once your task is healthy, we can use either container health or we can use that is recently launched, or DNS health, doesn't matter. Once it's healthy, we register as a backend to the Route 53 auto naming. And when you actually query for the same application, you can actually get multiple of those clients that you have multiple of those clients registered as packets for that. So this is client-side service discovery here. So just like in this case, I've looked for a particular app. Here I'm looking for web.myapp.local, and it returns this particular record for 10045. What are the benefits here? The first benefit is it is managed. You have two services that are managed, Amazon ECS and Route 53 auto naming. You don't have to install any new software. Second is it's tied to the high availability you get with Route 53 as well. And secondly, these are public APIs, so it's extensible. You can work across clusters, availability zones based on the high availability you want for your application, and it works across your AWS services as well. So with that, we are coming to a conclusion of the things that we covered in this presentation. The first is Fargate is a new launch type that is part of ECS, that you can run as part of ECS tasks. You will also be able to run for EKS tasks. If you're thinking, well, should I run my application as a EC2 launch type or a Fargate launch type, I would strongly suggest that if there's a new application, you're just running it, you are not running on EC2, and you don't have specialized requirements, think about using it on Fargate, because there you're making fewer assumptions about the underlying infrastructure, about dependent software that you have to install. Sometimes that is not possible. Sometimes you need a specialized army that you're using, or a particular instance type that you care about. You want to use GPUs, for example, and then it totally makes sense to actually use the EC2 launch type, because as you saw from a functionality standpoint, they still leverage the ECS orchestration and management capabilities that we have. So those are some of the considerations. You may have RIs, reserved instances, or you may want to use dedicated instances, sort of point-in-time feature differences between the two. That may dictate which launch type you actually may go for right now. Also, if you have feedback for it, we always love to hear that. That's how we built Fargate, because our customers told us to. So it is available in US East 1. We'll continue to expand that in other regions as we go on. We have plans for that. And you can use your existing, if you're an existing ECS user, you can use those task definitions with very minimal changes. You can actually run them on Fargate today itself. So with that, I'll conclude this presentation. We do have some Fargate stickers over here and at the back. We also have our service team members, Nate and Anuneet at the back, if you want to chat after the session. And please do fill out the survey if you do get a chance. Thank you.